All right, Algebra 1, lesson 5-6, number of solutions, the graphical version. I believe tomorrow is number of solutions algebraic, is that right? Let me check my notes. Yes, it is, the algebraic version. All right, so today's date is Tuesday, December 8th, 2020. Who would like to read our objective for the day? Go for it, Diego.
Graph equations in slope-intercept form and standard form to determine the number of solutions.
There it is. So unit 4 comes back and either haunts us or makes it nice and easy if we're really good at graphing these things. Remind me though, slope-intercept form, standard form, does anyone remember the general equation for either one of those? Ripley?
Is it y equals mx plus b?
Yeah, which one is that? Is that standard or slope-intercept?
Isn't that slope-intercept form?
It is indeed, yeah. So everyone write it down. Y is equal to mx plus b. And we can label this. M again is our slope. And b is our y-intercept. And then I have your steps down here. You're going to graph your y-intercept. Where's your y-intercept? It's going to be at 0, b. 0, b. You've seen this over and over again. Don't go left or right on the x-axis. Just go up and down, whatever this number is. And then the second step is you're going to use the slope to find your second point. And I'll just ask really quickly, slope, what's your favorite equation for slope? Only one person knows slope. Uh-oh, 2 people. Ashley?
Rise over run.
Rise over run. All right. Rise over run. Anyone else? There's another equation that you'd like to use. Jose, did you want to go for it?
Sure. Y1 minus Y2 divided by X1 minus X2.
Perfect. That one will also work. Any others? Yeah, Ripley?
Delta y over delta x.
Perfect. Delta y over delta x. All of those are perfect definitions of slope. So you start from your y-intercept and then you slope to find that second point. All right. That's slope-intercept. We're pretty good at that. Standard form, it's a little bit weaker for us, but still not too hard. Does anyone remember standard form? I need to enunciate better. Standard form. Giorgio? No? Okay. All right, standard form is your capital A, lowercase x, plus capital B, lowercase y is equal to capital C, where all of your capital letters, A, B, and C, those are just numbers. So as an example, let me give you an example down here, you'd have like, I don't know, 3x minus 4y is equal to 12. I'm just making up numbers here. That's what standard form would look like. And for this one, the way that you graph it is just graph the x-intercept, graph the y-intercept. But how do you do that? The x-intercept, I set some variable equal to some number. Can someone help me? What do I do to find the x-intercept? Remind me. I see Diego has his hand raised, but I'm going to see how many other people remember. X-intercept. 2 people have their hand raised. Let's go with Giorgio.
For y, I plug in 0.
Yep, set y equal to 0. And therefore, to find the y-intercept, Diego, you would?
You would, I think I forgot. Do the same thing to x. You make x equal 0.
There it is, yeah, substitute 0 in for x. And you'll find the y coordinate. Perfect. All right, so let's go ahead and practice doing these things. Example number 1, graph the system of equations. So I gave you one of each type. The first type is standard form, x plus 2y is equal to 4. So let's go ahead and try to do this one. And you can actually do this in your heads. I know you can't really, I can't show this because I'm not on the board, but like put your thumb over the y. That's essentially setting the y equals 0. Like cover that 2y up and you say, oh, x is equal to 4. So that's one of them. X is equal to 4. And now put your thumb over the other one. Put your thumb over the x, and you get 2y is equal to 4. Oh, we can do some mental math here. Divide both sides by 2, and you guys are already holding up. Yes, it is indeed a 2. So y is equal to 2. Look how easy that was. There's no like super hard math you had to do there. So you just go ahead and graph the x-intercept at 4. So go 1, 2, 3, 4. And graph the y-intercept of 2. And those are your 2 points. Make a line. Sketch a line because you don't have rulers unless you have a ruler at home. So what is that going to look like? Like that. So I'll do that first equation in blue, and then I'll do the next equation in a different color. Let's use orange. All right, that was standard form. Now we go into slope-intercept form. How do I know it's in slope-intercept form? Well, before it was an x and a y equal to a number. It looked like this form up here, and now I have a number in front of x plus some or minus a number. It looks like this thing, this slope-intercept form. So someone help me. First step. I give you your first step right here. So first step is to graph your y-intercept. What is the y-intercept, Alden?
The y-intercept is 1.
1. There it is. So we'll graph 1. And then the slope is going to be used to find the second point. I'm just reading off step 2 here. So use the slope to find the second point. Remember that the bottom number tells you how much left or right you're going to be going. So if I have if slope here is equal to -1/2, that means 1 will be your up/down number. And typically, if the bottom number is always positive, then that means it's always going to be right. If the bottom number is negative, that would be left. So obviously I'm going to be going 2 right. Am I going 1 up or 1 down? Can you guys all on your cameras do up, thumbs up, down, thumbs down? Am I going up or down? 2 right and then up or down 1? And the thumbs downs have it. Yes, we're going to go down. So 2 right, down, or yeah, 1, 2 right, down 1, 1, 2 right, down 1. And I can do the reverse of that too. I can go instead of 2 right, I can go 2 left. And then instead of going down 1, I go up 1. So 2 left, up 1, 2 left, up 1. And then connect those with a line. I'll use this color. And so before, if you remember all the way back to lesson 5-1, the answer to a system of linear equations is wherever the lines cross. These lines don't. They never cross. And there's a word for that. It's called what? It starts with a P. Does anyone remember that word? These lines are, yeah, Alden?
Parallel.
There it is. And if everyone can write it down too, when these 2 lines have the same slope and different y-intercept, so they're called parallel. So parallel, what does that mean? That they have the same slope and different y-intercept. Because if they have the same y-intercept, then they would be the exact same line. So they have to be at least shifted away from each other. Yeah, so they're parallel. There's no intersection. So if you come down here and ask, how many solutions does the system have? This another way of asking the same question is, how many times do these lines cross? How many points in common do they have? And everyone can hold up. Yeah, I already saw people doing it. It's 0. They never cross. 0. So you can say 0 solutions. You can say no solutions. Either one of those works. I think on Khan Academy, it's no solutions. I'm not sure. I haven't done the homework in a while. Not for a year. All right. Give me a fist of 5 on example number 1. How well did you follow that? I'm getting 5s from Ripley, 4 from Diego, 5, 4, 5.
3.
Okay, and Carlos? Carlos, ¿cómo mucho entiendes esto? 5,
Tres.
4,
Tres.
3. Okay. ¿Tienes preguntas para mí?
No.
Okay. Let's try another example. All right. There it is. Go ahead and practice it on your own. I'll give you guys a few minutes to try it out. Obviously, one of them is going to be in one form, the other one in a different form, so you get to practice both forms. And then we have kind of the summary table on the backside that we're going to be doing. So you can go ahead if you want. So please work on this now. All right. Who can help me with the first one? Who can help me graph 2x minus 2y is equal to -6? Go for it, Diego.
So what you do is you divide -2y into -6, which you would get a positive 3y. So you would graph it on the y-axis, 3. And then
Perfect.
and for 2x, you would divide that into -6 and get a -3x. So you would mark the -3x on the x-axis.
All right. And then you make a line that goes through those points. All right. Thank you. So again, both these came from this equation. Yeah.
Your screen's paused, like it's frozen.
Oh, it's frozen? Oh, sorry. Thank you for letting me know.
No problem.
All right, so we got the y-intercept, we got the x-intercept, we graphed, we have the first equation done. All right, what about this second equation? Y equals -3x minus 1. How do we graph that? Another volunteer, please. Show me how well you mastered Unit 4. Go for it, Giorgio.
You put a mark at -1. So like y -1.
Oh, okay. On the y-axis, got it.
And then graph the slope, -3x. So it's gotta go down.
Okay, it's gonna go down. How much?
Over by 1.
Right one?
Yeah. And then down 3.
Right one, and then down 3. Okay, right one, down 3. Then we can do the reverse of that as well. So instead of right one, down 3, go left one, up 3, left one, 1, 2, 3, left one, up 3, left one, 1, 2, 3. And change the color of our line. Nice. All right, thank you. Okay.
Oh, I get it.
So
Max.
again,
Oh.
What's up, Jose?
I get it now. Like it was harder before, and then now I get it.
Oh, nice. That's good. All right. And then finally, we ask ourselves the question, how many solutions does this system have? And everyone hold up the number of fingers. Is it 0? Is it 1? Is it 3? Is it 5? Everyone is holding up a 1. Yep. It's just one solution. It crosses once. There it is. It crosses that one time. So we come down here and say 1 solution. Nice, nice, nice. All right. Give me your fist of 5 again for example 2. Hopefully you're following even better than before. 5, 4, 5, 4.
4.
4. Nice. 5. Y Carlos?
4.
Ah, nice. All right. So I'd say our average there is about 4.5-ish. All right. Finally, the back set. So getting some vocabulary in here. So a solution to an equation. We've talked about this before, but this is every point on the line. If I'm just talking about one linear equation, or just any equation for that matter, any sort of curve, if I have a curve like this, I say If I'm just talking about that one line, this is a point that is a solution to the equation. This is a point that is a solution to equation. I'm just talking about one equation here. I'm not even talking about a system of equations. Just one line, any point on that line is an answer, is a solution. So it's every point on that line, AKA it is the line. The line itself is the solution. And that's what it means to graph the line. It's kind of cool. It's a graphical way of saying these are all the solutions to this equation. So now that we've turned it into a system of equations, not just one equation, it's multiple equations, it's the points. And maybe it's just one point. So I'll put points in parentheses S where the equations intersect. This is all review from 5-1. You've seen this before. But this is kind of the cooler way of looking at this. So the number of solutions in different forms down here, I'm going to graph one solution, 0 solutions, and infinite solutions. I don't know if you've ever seen infinite solutions. Let's try this. So one solution, we saw that. For this graph right here, one solution, the graph, what does it look like? Well, it looks like this. This is a graph with one solution. So over here, go ahead and just graph 2 lines that cross each other once. Choink, choink. That's one solution. Why? It crosses one time. What about the graph of 0 solutions? You've seen that already as well. The graph of 0 solutions looks like this. It's when you have parallel lines. Good morning, Haiti. Sorry.
Okay.
0 solutions is parallel lines. So we're going to go ahead and graph any sort of lines, but I can do a different color for my second line. Any line that is parallel to the first line. I can maybe grab them and I can shift them wherever I want. It doesn't matter where they are. There they are. Sure. That's 0 solutions when I have parallel lines. So does anyone have an idea of how we could have infinite solutions?
I do.
What is it, Jose?
Like sound lines, like wobbly lines.
Sound. Wobbly lines? Oh, okay. Yeah, that is definitely infinite solutions. We're not quite there yet in terms of just linear equations, but yes. So I think what you're saying is something that looks like that and something that looks like this. Yes, that is infinite solutions as well. Nice. How would you do that with just a straight line, just linear equations?
In the same line, like both in one.
Exactly, yeah, the same exact line, one on top of the other. So if I have some sort of blue line, let's put it, I don't know, just randomly right there. Then if I draw another line, that line is on top of, oh, it's not gonna let me draw it on top of, I'll have to draw it over here and then move it on top of. That line is on top of the blue line when it is the same line. So it's kind of hard to see in my notes and probably hard to see in yours. So maybe you wanna label this, it's the same line, same exact line. That means it's infinite solutions.
Oh, can I draw the sound line?
I mean, you can, but remember that for unit 5, we're in linear functions. Eventually we'll do quadratics and have curvy lines in the future. I mean, yeah, you're right. That is infinite solutions. It's just not a linear equation or a linear solution for infinite solutions.
Okay.
So, and this is going to transition you into tomorrow's lesson. I want to analyze the slope and the y-intercept of all of these lines. So for these 2 lines up here, they're slopes. Do they have the same slope or do they have different slopes? Those are the only 2 options, same or different. For these 2 lines right here, and let's do all of us, and Haiti, if you could turn your camera on too. Let's do all of us thumbs up or thumbs down. Thumbs up is they have the same slope. Thumbs down, they have different slopes. For one solution, these 2 lines, do they have the same slope, thumbs up, or do they have different slopes, thumbs down? I only see 1 thumb. I need more thumbs. Take a guess. Stab in the dark if you have no idea, but analyze it. Do they have the same slope or do they have different slopes? And I'm a little bit worried because most people are putting thumbs up. It's actually thumbs down. They have different slopes because this slope is like, I don't know, -2/3 or something. And this slope is like 1. They're different numbers. They have to be different numbers. So this is going to be different. The slopes are different. What about the slopes in this one? Where I have 0 solutions. Are the slopes the same, thumbs up, or are the slopes different, thumbs down? I see 1 thumb so far. Should take too long to write the notes that we've done so far. These slopes, the slope of the blue line and the slope of the orange line. There are 2 slopes. Are they the same or are they different? And there's, the majority has it correct. These are the same. And I even wrote that in our notes up here. When I was talking about parallel lines have the same slope. And what about infinite solutions? When it's the same line, is it the same slope or is it different line or a different slope? Yeah, can't speak. Thumbs up, thumbs down. The thumbs up have it. It is the same slope. Now let's look at the y-intercepts. On this one, you don't actually care. So just cross it off. You can scribble it out, do whatever you want. Don't worry about it. As long as the slopes are different, that's all you care about. It doesn't matter. Maybe instead of doing X, you can say doesn't matter. Doesn't matter. And if you cross it off, that's fine as well. All you care about, if the slopes are different, then it's one solution. If it's 0 solutions, where's the y-intercept? So I see a y-intercept here and here. Are they the same? Are they different? Really quick thumbs up, thumbs down. Y-intercepts, are they the same? Is it the same height that they go through the y-axis? Yes, no? Most of you have it correct. It is different. Thumbs down. And finally, to end off our notes, if it's the same line, this y-intercept and this y-intercept, is that the same y-intercept or different y-intercepts? Thumbs up, thumbs down. Just really quickly, make sure you're awake. Yes, you guys all got it. It's the same. I mean, they should all be the same for this one. It is literally the same line. So just looking at this chart should be able to tell you, okay, like I don't even know what the graph looks like, but I can tell, oh, if I just look at the slopes, oh, the slopes are different. Ignore everything. You're done. Once you know the slopes are different, you know the answer is just one solution. If the slopes are the same, though, then you have to say, okay, well, I don't know if it's infinite solutions or a 0 solution, so now I have to compare the y-intercepts. All right, so that concludes our notes 5-6. Make sure you're writing summaries. Make sure you're uploading your notes. Very few people are uploading their notes online. You need to be doing that. I'm going to start grading that right now.
Oh, I haven't done that before.
Okay, I
Do we
can help you
take
get
pictures
started.
and upload them to the same Google Slides?
Yes, I can start doing that. I forgot to do that.